Hi everyone, and welcome to this first video in the new topic. We're going to look at more trigonometry. So this builds on the knowledge that you should already have on the SOHCAHTOA type trig that we've done before, and some of the work we've done on exact values of trig functions. The topic areas we're going to look at are listed to the left. Specifically in this video, we're going to look at graphs of sine, cosine and tangent, and then we're going to extend it in terms of how we can use these graphs to be able to solve some trig equations. Now you might remember that some of these values from Formula Friday, we've got these sine values, 0, a half, root 2 over 2 and so on, and these are all increasing. It might not be obvious straight away, but these are all over 2. 1 is smaller than root 2 and root 2 smaller than root 3. These are all increasing from 0 up to 1. You'll notice that the values of cos are exactly the same as sine but going down the other way. And tan seems to do something different. It starts at 0 and goes up to infinity. And this is only between 0, 30, 45, 60 and 90 degrees. What we need to do if we're going to start thinking about graphing these is extend it beyond what we've done with right angle triangles and start to see what happens with the bigger values. Now, at 180 degrees, and 270 and 360, it's a bit odd. It seems to go 0 minus 1 0 as if it's sort of repeating again. So we've got these multiple appearances of 0. Similarly with cos, we get lots of appearances of 0 and 1 and minus 1, and then in between the 1s and 0s we get these sorts of values appearing. And tan, again, 0, infinity, 0. To make sense of what these values are telling us, it'll be a really good idea to start looking at your graphs. Now, if you've downloaded from class charts the pictures of the graphs, we can start to look at those together now. If not, you'll need to draw these out in your book. So there'll be times that you'll need to pause the video to be able to do that. Okay, and this is what the sine graph actually looks like. So from our last slide, you'll see that we talked about it increasing between 0 and 90, and we can see that that's the case here. What might not have been as obvious is that then it starts to decrease again, and down to 0 at 180, and it keeps going down in this very sort of wave-like pattern until we get to 360, and then it doesn't stop here. It actually continues on. So this is just one of the waves, and it's called periodic. So in this particular instance, has a period of 360 degrees, and it just keeps going. So this graph keeps going like this, and it also goes down here as well into negative values. So it's just this sine wave keeping going and going and going. There's some interesting things here that you really need to learn about. So in terms of what's happening, you might see that it's symmetrical between here and here. So you've got like a line of symmetry at 90 degrees. We're going to use that property later on when we start to solve some equations. Equally, you've got this part of the graph down here, which is symmetrical around this line at 270. So again, we can use the symmetry. The values that we're specifically looking at, can you see how it goes up to 1 and down to minus 1, and it doesn't go any further? Some of the key bits of information you need to be able to know from the graphs as well. So at 90 degrees, at its maximum at 1, it comes back down at 180 to be 0, minus 1 at 270, and then back up to 360 at 0. So these are the values that we need to learn in terms of sketching our graph. I'd always encourage sketching it out, making sure that you label on 180, 360 and 0, up to 1 and down to minus 1. And then we can start to visualize the graph in a bit more detail when we're using the symmetry to help us. Next, we'll have a look at the cosine graph. So again, you'll see it's very similar. Starts at 1, down to minus 1, 0. We've got this one period. So here, again, it's periodic between 0 and 360. It does continue. It'll start to come down here. And again, on this side, it'll start to come down and keep going and going. Again, we've got the symmetry. If we're looking between here and here, between 90 and 270, you can see the bottom of the graph is symmetrical, as is the top. So in this whole section, between 0 and 360, we've got a line of symmetry at 180 degrees. Again, we're going to use that later on. The numbers that we're specifically interested in, when we start to sketch out cos, we start at 1, we come down and back up. When we go down as far as -1, and it crosses the x-axis at 90 and 270. So again, when we start to think about sketching these out, these are the important bits of information that we're looking for. Then if we start looking at tan this time, it's very different, and you can see from the values we had in our Formula Friday, exact values started at 0 and went off to infinity at 90. Now the next value after 90 is all the way down at minus infinity, and it starts to increase again, going to 0 at 180 and back off up to this asymptote here. Now an asymptote is a line where the graph tries to get as close and close and close and close as it can, but never quite gets there. So we've got these things called asymptotes in the tan graph. We need to make sure that we've got those in fairly clearly if we're drawing it out. And again, one of the things that you'll notice here is it starts at 0 and it repeats every 180 degrees. So again, we're going to use this 180, adding on 180 for the tan graph. Again, it's periodic. In this case, every 180 degrees, it repeats. So let's see how we might use the graph in an actual context then. So number one, you need to be able to replicate the graphs. You need to be able to sketch them and draw the information on. Second thing that we're going to do is use the graph to help us solve some equations, and then later on in a video later we're going to look at how we might transform the graphs, moving them up and down and stretching them and seeing what happens there. But right now we're going to look at solving some equations. So if we're going to solve sine x equals 0.4, we use our calculator, we do the inverse of sine of 0.4, and we're going to get a value coming out on our calculator. This is called the principal value. It just means it's the first value that's closest to the x equals 0. Closest to the 0 on the x-axis. So from there, we can start to think about where the other values might appear. So we've been asked to do it between 0 and 540. So if it was as easy as just getting that one value from the calculator, we're missing something. The other values we're going to get from the graph. And so here's our graph, all the way from 0 up to 360. You can see how it continues up to 540 down here. Let's see if we can work out where the other values are going to be. Now 23.6, it doesn't matter about it being exact, as long as you can roughly see what's going on, is somewhere here. Okay, and if we were to draw a line across, you can see this is approximately 0.4 up here, which is what we were doing before. Okay, so here's my line at 0.4. Now you might see that this dotted line crosses the sine graph at this point, and here, and here. And so what we're going to do is use the symmetrical nature of the graph to work out what this value is. So if I've gone from here at 0 right 23.6 degrees, to get this value down here, I'll have gone from 180 back 23.6 degrees. So this value is going to be 180 minus 23.6, because that distance is the same as this distance here because it's symmetrical. So there's my next answer. Now this value up here is 360 and adding on that same distance again. So 360 plus 23.6, which gives me my next answer. And then my final answer was 540. Again, we've got that same distance, we're coming back. So 540 minus 23.6, which gives me my final value. So when we're trying to solve equations and we're looking at a big range like this of values, then we're going to get multiple solutions, and we need to make sure we get our principal value from the calculator, and then all the others, we're going to sketch out the graph, and we're going to use the symmetry of the graph to calculate the other values. If you've not written this down just yet, pause the video, make sure you understand this bit, and then we'll have a look at one more example before it's your turn. Okay, so this time we're going to have a look at a tan version. So tan x equals 0.5. We're going to use our calculator first to get our principal value. So we're going to undo the tan. We're going to do inverse tan to get x is 26.6 degrees. Okay, now we've been looking at between 0 and 360. So let's see where the other solutions come from. We're going to draw our tan graph out. So here it is. I've drawn the asymptotes in red so you can see clearly what they are. And the first value is at 26.6 degrees. So again, it doesn't have to be exact, as long as you're roughly in the right kind of place. You can see, here's the first one. We're going to draw our line across. So this up here, we're saying is 0.5. And the next time it appears is over here. Now, from the last slide, when we were talking about tan, we said it repeated every 180 degrees. So our next value is 26.6, add on 180. And then the next time it's going to appear is going to be after 360. And we're only interested in it between 0 and 360. So we've only got two solutions, this one and this one. Okay, now there is 10 questions on a worksheet that I've set on class charts for you to have a go at based on this skill. There's also some questions on Dr. Frost Maths, but we'll talk about that later. So have a go at the questions now. The answers are going to come up next, so you can pause the video at this point and then look at the answers next. Okay, and here are the answers to the worksheet. So again, you can see you've got multiple solutions. If any of these you don't agree with, get in touch with me and I'll talk you through where they come from. Each time I would recommend doing a little picture because number one, it's really starting to cement in what the sine, cos and tan graphs look like. You're going to need those just at your fingertips really. And then second of all, it helps when you're using it for the symmetry to find your solutions here. Okay, so here we are, we're at the end of this video now. As I mentioned previously, there's some work on Dr. Frost Maths for Tupton students that I've already set. If you're watching this video from a different school, I'd highly recommend registering with Dr. Frost Maths. It's brilliant and it's free, and you will be able to practice some of your GCSE questions on there. Okay, that's the end. Thank you very much for watching. See you soon. Bye.